Dear students, welcome to virtual class of Municipal Corporation of Greater Mumbai. I am Sreekumar. The class is for 7th standard students. Subject is mathematics. Let me begin the class.
Dear students, this is part 2 of the topic perimeter and area. In the last video, I could make you understand how the perimeter can be calculated and how it can be applied in different situations, especially when the figure is of what we say rectangle and squares, and different situations were given in the practice set number 45. I hope that you must have gone through it thoroughly. Now we will move ahead with the same topic, perimeter and area, where you will be getting more idea about the concept of area with respect to in fact right angled triangle and other triangle, as well as a basic concept about surface area. That is this video about. So let me proceed. The topic is area of a right angled triangle. The last video you studied about how to calculate and apply the concept of perimeter and area of a rectangle and square in different situations. I think you must have done the problem set number 45 and ready to follow further about area of a right angled triangle. You know what is a right angled triangle and how it looks like. You are very much familiar with it. And in a right angled triangle there will be an angle which is 90 degree, which is making the right angle a right angle, correct? And we normally name right angle with the 3 English alphabet ABC, so we can name this as a triangle ABC. Now the topic over here is finding out the area of a right angle triangle. In order to develop or to find out the area of a right angled triangle, we need to start from a rectangle. Rectangle, you studied it in detail in the last session, right? In that you found that how to calculate perimeter of a rectangle and also the area of a rectangle. In the case of a rectangle, we know the rectangle is named as rectangle because a rectangle is also having 4 right angles here, and this is the length of a rectangle, this is the breadth, and you studied about the formula to calculate the perimeter is 2 into L plus B, where L plus B stands for length and breadth, and area can be calculated by the formula length into breadth. These all things are in detail explained in the last video. So in order to get the formula to calculate area of a right angled triangle, we need to recollect and apply the concept of area of a rectangle. Okay. This is a rectangle. Okay. And this colored area we can consider as the area of the rectangle. Now suppose that we divide the area of the rectangle into 2 equal half. We need to draw a diagonal from one corner to the other corner of the rectangle, one vertex to the other vertex, in this way. Now we could divide the rectangle into 2 halves, or the area of the rectangle into 2 equal halves. But at the same time, we know that the area of a rectangle is calculated by the formula length into breadth. Keep this in mind. This is the length and this is the breadth. Correct? If I simply quote length as L and breadth as B, the area can be written as length into breadth L into B. But by a construction, the construction of a diagonal, we call this as diagonal. We name this as diagonal. We have divided this particular rectangle into two equal halves, where we are having a right angled triangle here, another right angled triangle here. So we know that this area is equal to 2 into area of two right angled triangle, correct? That means if you need the area of one right angled triangle, what you will have to do? Area of a right angled triangle from this construction, we will write half of it, that is a length into breadth upon 2. Correct? If it is length into breadth upon 2, it is a formula to calculate the area of a right angled triangle. Okay, so area of a right angled triangle can be calculated by taking the half of the product of the side forming the right angle. How could we conclude that? We concluded it by this experiment or this construction and the formation. And if we separate out this right angle triangle some way, and you look at the right angle triangle alone, we cannot say length into breadth. We already said product of the side. This is one side, this is another side. So instead of saying like that, we can say this as base of the right angle triangle, this as height of the right angle triangle. Basically, it is a product of the angles forming right angle. Correct? So in general, we say the area of right angle triangle can be calculated by the formula half into base into height. Because we named this as base, the other as height. It can be in this form also. If the right angle triangle is kept like this, the smaller can be the base, this can be the height. There is no any hard and but it is a product of the side, but for convenience we write it as base into height. Okay, so half into base into height is the area of a right angled triangle. This is one formula that you should remember. If this is the formula to calculate the area of a right angled triangle, can we apply this to calculate the area of other types of triangle where it doesn't look like or it is not a right angled triangle? For that we need to do more construction and try out. So let us think about this particular triangle. Doesn't look like a right angled triangle, but we can see there can be a base and height for this triangle also. If you draw a perpendicular here, perpendicular, you know, a 90-degree angle here, we can see that this particular, if I name this triangle as P, Q, R and this point as M for convenience, and this one can be named as the base from QR. QR can be named as base. The total length of QR can be named as base, based on which the triangle is constructed, and this can be named as height. Correct? So if I do the operation, what is that? Half into base into height, if I apply, can I get the area of this triangle? Because it is not a right angle triangle, but it's a triangle. Can simply by multiplying half into base into height, it will give us the area of it. For that we are going to do some construction. This particular height we have already taken, and it has divided this particular triangle which is that PQR into two triangles. Which are they? One triangle is triangle PMQ and the other triangle is triangle PMR, correct? PMQ and PMR are the two triangles by which the triangle PQR is formed. So if the area of triangle PQR must be equal to the area of triangle PMQ plus the area of triangle PMR. That means this area plus this area together, if added, will get the area of the big triangle PQR. Now these two are right angled triangle. Look here, because of the perpendicular, these two are right angle at M, both cases. So we can apply the formula here. What is the formula of right angle triangle? Just now we learned that it is half base into height. That is very clear. So this is the base of triangle PMR and this is the base of triangle PMQ. So we have base and common height. No problem. We will write that over here. How can I write? I can write this base as, in the case of PMQ triangle, if I write half into the base as QM into the height in this case is equal to, this is the height which we are considering as PM, plus in this case half into the base in the case of the other triangle PMR is, MR is the base, correct, and height is again PM. So what we can understand is that in this case half QM into PM, half MR into PM, we are applying the formula half base into height in both the cases, right? So why can't I write in this format? Half into, half is common for both, right? Half is common for both. So we are having half common, and why can't we think about length of QM plus length of MR, correct? And PM is common. This is, we are adding this with this common, and here it is PM is common for both. So this became two bases taken together, two heights taken together, one time multiplied by half. And what is this QM plus MR? QM is this, MR is this. So why can't I write it as, instead of writing like length of QM and length of MR, I can write it as half of base into PM is height. That means what we understand is that if there is a triangle which doesn't appear like a right angle triangle, consider any one of its side as base, and if you can get the height of it, so take the height and apply the formula half base into height, and you will get the area of that triangle. Now you may be thinking that is it applicable to all triangles? For that we should try with more triangles. One triangle gave the answer, and that doesn't make us sure that it will be right in the case of every triangle. We have to do with more triangles. That is what mathematicians do, and then they make us understand by giving some example. That is what is happened here. We will try with another triangle. The triangle can be in any format, you know that. The triangle, this triangle is almost look like this, right? Another triangle can be like this. Now, if you consider this as base, where is the height? Now, the definition of height of a triangle you have studied. The definition of height of a triangle, if you take this as base, then you should have a line drawn from the opposite vertex to the base, and it should be perpendicular 90 degree. Correct? So if this is the base in this case, so we need to have a height line drawn from the, this is the base. So opposite vertex is this. From here you should draw a perpendicular to the opposite side, and that becomes the height. Whenever we talk about height of a triangle. Understood? The triangle can be in any format. It can be like this. This is a triangle. You consider this as base, you have to extend this, draw a perpendicular from here, make it a 90 degree perpendicular. This is the height then. Please understand. Keeping this in mind, let us go ahead with another. This is another triangle. See, almost as I said. Now in this triangle, if we apply the principle of area of triangle, half base into height, we need to put a baseline as this base. Let us write base over there. To get height, I told you need to extend this, draw a perpendicular, mark it as height. We are doing it, we will recheck it. After doing all this, we have to check it, and let me for our convenience name it as P Q R as the original means the first triangle which was given earlier, this triangle PQR, and this as base. Correct? This is an extension done, and this is a height drawn, right? And let me put as M like last triangle. It was from M the perpendicular was drawn. Now if you ask me that triangle, it was an addition of two triangles gave the area of the given triangle. Here we have a right angled triangle. What is that? PMR. From that triangle, if you could subtract this area, you will get this area. This will be the principle we will be applying. That means now it looks like a right angle triangle. From that triangle, you will remove this much area. So you will get the area here. Correct? So we will do accordingly to get that, whether it will give an answer. Half base into height will give the answer for any kind of triangle. For that, what I should do, we should think about the area of the bigger triangle, the whole triangle, and to get the answer. So what we need is the area of triangle PQR. PQR is this red colored one. To get that, you should go for the area of triangle PMR minus, subtract from that, the area of triangle PMQ, this one. Whatever we are getting will be the area of triangle PQR. And triangle PQR is not a right angle triangle, but PMR and PMQ are a right angle. So we can apply the formula half base into height, because we proved it from rectangle. So half of base in the case of PMR is nothing but MR, and height in this case is again PM. And in the case of PMQ, this one and this one, MQ is the base, half of MQ into the height over here is length of PM. Correct? Again we can say that, we can rearrange it as half into MR, the length of MR minus MQ, correct, into PM. PM is common. Look at this particular statement. MR, this is a whole length, minus MQ. So naturally QR became the base into M. So I can write it as half into QR, the length of QR, into PM. When we come to this format, look at the original triangle. What is QR? This is QR. This became the base. And what is PM? PM is the constructed height. That means in this kind of triangle, we need to construct a height drawing a perpendicular from the opposite vertex to the base. That height is the height of the triangle, as we know, and if you multiply that height with the base of the given triangle, you will get the answer. So we will write area of triangle PQR also. Here in this case also we got it as half into base into height. So this formula is applicable for any triangle. If you can get the height of it, you can. And the height of the triangle is nothing but considering any side of the triangle as base. Draw a perpendicular to the opposite vertex from the base, and that is the height of that triangle. Sometimes you need construction like this to draw, otherwise it will be within the triangle that you can draw a height. Drawing is different, concept is different, and it will be given in the question very clearly what is the height of the triangle. Sometimes you will be asked to find out height, sometimes you will be asked to find out base, sometimes you will be asked to find out the area, but the formula is simple and same. Another thing, whenever we are applying this kind of formula in a real situation where we are applying the formula, you should check that whether the units are same. If all are centimeter, all must be centimeter, otherwise meter. If it is meter, all should be brought into meter accordingly, and then you have to solve the sum. Okay, that part is simple. The only important part is what is the formula to calculate the area of a triangle is proved, and it is clear to you now. Okay, here is a question. If the sides that form right angle of a triangle are 3.5 centimeter and 4.2 centimeter, find the area of the triangle. The question is very simple because both base and height are given. You need to simply apply the formula of area of right angled triangle. Simple application. You will simply write that half into the base height कुछ लिखे नहीं तो भी चलेगा, because the product of sides forming the right angle, product of sides forming right angle. So what you will write, half into, it is given sides that form the right angle of a triangle. To make you familiar with, you simply have to multiply 3.5 centimeter into 4.2 centimeter. You will solve it and get the answer. 7.35 square centimeter you will get on solving the sum. Simple application of it. Very rarely you will get a simple question like this. If the base of a triangle is 5.6 centimeter and height is 4.5 centimeter, what is its area? Again, base is given, height is given. You are simply asked to find out the area of the given triangle. Area of the triangle is calculated by the formula half base into height. Half the base is given as 5.6 centimeter and height is given as 4.5. In this case, height is written, base is given in the question. You will copy it and start, and base is equal to 5.6 and height is equal to 4.5. You will multiply and you will get the answer. And you should know that it is given centimeter here, centimeter here. After multiplication, you will be getting the answer 12.6. And centimeter into centimeter, you can write centimeter square, or you can write 12.6 square centimeter. These are the two ways of presenting the answer. Both way it is right. Either square centimeter you write, or you write centimeter square. So this knowledge of formula to find out the area of a right angled triangle will help you to solve the problems given in problem set number 46. Even in the case of other triangle, if base and height are given, you can calculate the area by the formula half into b into h. Now we will use b into h. No need of saying base and into height while saying. You can write it very well. Okay, so that's one part of this video. Next we have to understand the concept of surface area of a three-dimensional figure like cube and cuboid. Here there are two figures on the screen. It is a three-dimensional figure. It is not simply length and breadth, depth is also given. That's why the dotted lines are drawn. And this figure is that of a cube, and this is cuboid. A cube is having all the sides, 6 faces of it equal in size, all sides equal. It is a three-dimensional formation out of a square having all 4 sides. When it comes to cuboid, it has got 6 faces, just like if I say this as front, this as back, there is no front back like this, and this is up and this as down, this on my right and this on my left. It depends upon how you look at it. You have 6 faces in both the cases. And in the case of a cuboid, it is a three-dimensional figure developed out of a rectangle. So 6 faces are there. Each face is a rectangle here. And we can say, if I simply color it for understanding it better, this face, which I can say that facing us, is having a similar exact face over here, the back of it. So 2 such similar faces, and here on my left and right 2 similar faces having, it's also a rectangle in the shape, and on top and bottom we are having rectangle again similar in its size and shape. So we are having 6 faces, and opposite faces we can say they are almost having same area, and length is there, breadth is there, and there is a height or depth we can think about that also. The 3. If you are asked to find out the area of such a cuboid, you need to have the total of 6 faces, but we came to know that among these 6 faces there are 3 pairs of faces. One, if I write a length over here, this is length, this is length, this is length, this is length. Understood? And if I say this is breadth, this is breadth, this is breadth, and this is breadth, then I can see this as height, this as height, this as height, this as height. So if I think about making 3 pairs of faces of it, one I can write length into breadth, which is common to us, and such are there 2. So if I name this cuboid in such a way that if I write A, then B, I will use another color so that you can see it differently. This is A, this is B, suppose that this is C, this is D, then I'm having E, F over here. This is all my convenience I am writing. You can name it in any format. So I am having all the 6, all these vertices in different names, A, B, C, D, E, F, G, H. So if I think in that way, if I consider length into breadth, it is just like G, F, E, H. Yeah, G, H, E, F. That particular side I am considering, and we are having, it is having similarity with A, B, C, D. There are two such faces. And second, I am taking, I already took a length into breadth case, and if I am taking breadth into height, which is breadth here, this is the breadth and this is the height. This is the breadth, this is the height. Such also two are there. And if I consider the third pair, it is length into height. This is the length and this is the height, the front and back, I would say. Otherwise, if I use this particular vertex name, I would say GHCD and FEBA. So such two faces. So when we calculate the area of these length into breadth, breadth into height, length into height, and multiply the whole with 2, adding it and multiplying with 2, you will get the total surface area. Total surface area is the area of the whole figure. Surface is surface, you know, that which is can be felt or touched. Surface area is calculated in the case of total surface area. We are calculating the area of all the surface which are in contact with air. So in that case, we have to add all these things. So we get the area of 6 faces, or simply the formula can be written as 2 into length into breadth plus breadth into height plus length into height. This formula you should remember, and you should know L is length, P is breadth, H is height according to the cuboid. But when it comes to the case of a cube, that also has got 6 faces like that of a cuboid, but all faces are same and equal, and all the sides of equal length. If I put simply L over here, it is length L over all these are L. So we know the area of a square is L square. So such 6 faces are there. So 6 times we have to take. The formula becomes 6 L square. L stands for the length of the side. So my dear students, this is just an introduction about total surface area of a cube here and cuboid here. Please remember this. This can come as a simple question if your teacher is interested to evaluate that, but you will be learning more about this kind of 3-dimensional figures and its application level questions in coming years. You are in 7th standard now, surely in 8th and 9th and 10th you are having more and more about this kind of figures, so you should be ready for that. Okay, so these are some questions from your textbook, and just copied it because just to refer about it. See, it is given to find the surface area of the cube having following sides. You know, surface area of cube is calculated by the formula 6 into L square. You will apply it. Find the total surface area of the cuboid is given, so you know that 2 into length into breadth plus breadth into height plus length into height. This is the formula. You will apply that. Matchbox is coming here. Matchbox is having a cuboid shape, or matchbox is a subject here or a matter here. Why? Because it is having the shape of a cuboid. You will apply an open box. Whenever think about box and it is having different length and breadth, that is also a cuboid. And boxes are very common. Your geometry box or any kind of such box can be considered as cuboid, and apply the formula of cuboid in such case. Only 4 questions are given in the textbook that you will do yourself. They consider that just by doing 4 questions you will become expert in solving this kind of questions, and I too. Why? Because it is simple. Okay, so my dear students, try to do the practice at 47 yourself without taking any help from anywhere, because you don't have much questions over here, and that will make you strong enough to follow what is coming in next year regarding this kind of figures and structures. Okay, thank you.
Now click on the subscription button below to subscribe the channel, then the bell button to get the notifications of the new videos. Thank you.